Hello, everyone, and welcome to the Deploying Harmony Core Services on Linux and in Containers session. My name is Tyson Harris, and I'm joined by our presenter, Synergex Senior Consultant, Steve Ives. Steve has
Good.
worked as a technical consultant and trainer for Synergex since 1997, developing e-commerce applications and helping companies maximize their vertical market software applications. Steve has experience with networking, building and managing internet connections, and with security firewall solutions. He's proficient in several programming languages and has been involved in the development of internet and intranet e-business software applications. And so we're going to kick off Steve's presentation here in just a moment. Just as a reminder for anyone who hasn't sat in on one of these sessions before, there's going to be some time for Q&A after the presentation. So you can use the chat box on the right-hand side of your screen or the Q&A section, and we'll be sure to address any questions that you have after the session is over. If you have any technical issues, you can contact classes@synergex.com, and we'll post the email in the chat. And as a reminder, these sessions are being recorded. So without further ado, let's kick off Steve's session.
Thanks for joining us for this presentation where I will demonstrate how to deploy Harmony Core services to Linux platforms and later to Docker containers. Let's get started. As many of you will already know, Harmony Core is a software framework designed to make it easy for Synergy developers to build and expose powerful RESTful web services that allow client applications to interact with a Synergy application's data and business logic. Harmony Core services have traditionally been built with .NET Core 3.1 and we're currently transitioning to .NET 6. As this slide shows, Harmony Core has always required a Windows server to host the web service components, and there were two common deployment models. The diagram on the left shows a single system configuration that could be used if the application's code and data are all on Windows. All data access is local, and if traditional bridge is used to access the application's traditional Synergy business logic, the JSON RPC messages are sent via standard in and standard out. This configuration allows for optimal performance because all of the code and data reside on the same system. The diagram on the right shows a two-system configuration. The web service components are still hosted on Windows, but the application's data and code are hosted on a different system. That system could be any traditional Synergy platform. In this scenario, XF Server is used to access the application's data. And if the traditional bridge is used to access traditional Synergy business logic, then an SSH tunnel is used to transport the JSON RPC messages. While not quite as fast as the single server solution, performance is generally very good, certainly exceeding that of earlier solutions. So what's changing? Well, if you watch very closely as I click on the next slide, you will notice that you will soon have the option to host the Harmony Core web service portion of the solution, which is now being built with .NET 6 on a Linux system. As you may know, we recently added support for .NET 6 on Windows in Synergy 12.1, and the SDE team is currently in the process of adding runtime support for .NET 6 on Linux, first for Harmony Core services and later for other applications. This new platform is taking a little longer than we originally expected, but we are close to being able to release it now. As support for .NET 6 on Linux is a new platform, not a new feature, as I mentioned in my product update session, we did originally intend to ship this as an update to the 12.1 LTS release. But unfortunately, the required runtime code changes were more extensive than we originally thought, making that inappropriate. So we will be shipping this as a 12.2 feature release. So the new options available to you are to run a Harmony Core service entirely on Linux with local Synergy data and optionally traditional Synergy code, or to run a Harmony Core service on Linux, accessing your Synergy data and optional traditional Synergy code on a remote system, which can be any supported traditional Synergy system. Clearly, this is a really big deal for Linux customers, as data access can now be local, which will not only be super fast, but will no longer require XF Server configuration or licensing. So, how can you go about doing this? Well, the support for Synergy.net on Linux is runtime support. The .NET compiler and other development tools have not been ported to Linux and may never be. This means that development of your Harmony Core service still happens where it makes most sense, in Visual Studio on Windows. I should note that with the migration to .NET 6, Visual Studio 2022 is required, as that is the only version where Microsoft support doing .NET 6 development. And even though you'll be deploying and running your service on Linux, you will still be able to test and debug it directly from Visual Studio with a full debugging experience. Depending on your environment, you may have to install some components on the Linux side to make that possible, but for the absolute best and most integrated solution, I'd recommend using the Windows Subsystem for Linux, or WSL2, to run your Linux systems side by side with Windows for development. Of course, if you do want to migrate your Harmony Core service to Linux, you will first need to upgrade it from .NET Core 3.1 to .NET 6. And the Harmony Core CLI tool will do much of that work for you. And make sure you get the latest version of CodeGen also. You may need to check that your code doesn't use any Windows-only features, but that is fairly unlikely, as most of Harmony Core services are built from generated code based on templates that we provide. But one thing to check is that you haven't used any Windows-specific file paths, particularly in configuration files and similar, that may be used on Linux. So generally, you want to specify a different ASP.NET environment for your Linux deployments and configure the necessary file paths in the appropriate configuration files for that environment. When a developer is done developing a .NET 6 application like a Harmony Core service and ready to deploy it to QA or production, often using an IIS server, a tool called .NET Publish is used. The tool first builds the application, placing all of the application's binaries, along with the binaries for all dependencies and any other content files that may be required by the application, in a specified folder. When the publish completes, the folder contains everything needed to run the application on another system, including both the .NET and Synergy runtimes. When publishing an application, the developer specifies the target platform using the ---- runtime command line option. For Windows, there are several available runtime options, but for maximum compatibility, we often use a platform designation called Win7-x64. To produce deployment files for Linux, all the developer has to do is change the platform target to Linux-x64. Of course, there are a few more steps that a developer can take to make deployments as simple as possible. And as an example of this, when you create a new Harmony Core service from one of our new .NET 6 solution templates, we provide an example script called publish.bat. Let's take a look at what the sample publish script does.
Here we are inside a sample Harmony Core solution, and you can find the publish scripts in the solution items folder. You'll notice there is a file called publish.bat, which we'll look at in a moment. There is also a publish settings.bat, which allows you to define what the publish.bat does. Generally, you have to create this file yourself and put the content in there, and the instructions for doing so are actually found in the comments inside publish.bat. But if we take a quick look at publish settings.bat, what you will find is that there are various settings that you can specify to guide and control what the publish process does. So we are electing to say, yes, we are using traditional bridge. So we'd like to copy the traditional bridge runtime files into our distribution. We are basically saying we would like to create a zip file of the published content, not just have a big directory. And we're choosing not to date and timestamp the name of that zip file. You'll see what it's called when we look at the publish script. We're also specifying that once we've finished zipping, we would like to take a copy of that zip file and place it into a different location. And in this case, it's in a Docker subdirectory. You'll see how that comes into play as we go through the rest of the demonstrations. We're not using it here, but we do have the ability to specify that we FTP the zip file if we want to deploy it to some remote system, and we provide the FTP server and username and password and so on. So that's what the configuration file looks like. The actual publish script itself, if we it gives you a description of the kind of things it's doing at the top, and it also here it's showing you an example of how to create the settings file. But let's just quickly go through what it's doing. I'm not going to go through every line, I just want to give you a flavor of what's happening. So essentially what we're doing here is we're saying if there is a publish file, then go ahead and call it just to establish the settings and the environment. Here what we're doing is determining that we're going to use a subdirectory called publish to be our deployment directory. The script is going to prompt you, well, it's going to look for a command line argument of Windows or Linux. Those are not case sensitive. And if you do not specify one, it will then prompt you to enter, do you want to publish for W for Windows or L for Linux? And based on your command line option or the option that you enter, it will configure the platform and the runtime we're targeting. Here's the Win7 x64 platform and the Linux x64 platform that we mentioned earlier for the .NET publish command. Then it basically does the publish, so it checks if the deployment directory is already there, and if so, it clears it out. In fact, it deletes the whole file, the whole directory and all its files. And then here's where we do the publish. So here's the .NET publish command. You can see we're building it in this demonstration for any CPU debug, so we can do remote debugging with it when it's deployed, and we're using the runtime that was determined by the platform that we picked earlier. Once the deployment is complete, essentially then we process some of the other options. So we're saying, are we including traditional bridge files, in which case we copy in the traditional bridge binaries, and also if we're on Windows, we copy in the batch file, or on Linux, the shell script that is used to start the traditional bridge session. Here's some of the other options. We're copying in a web.config file and replacing the one. Publish creates one, so we're replacing the web.config file here. The reason we're doing that is if we look in our services host, if we look here in web.config, we're specifying that our deployed environment uses an ASP.NET Core environment called production. In Visual Studio, we're running in an environment called development. And what that allows us to do in the services host, you'll see different app settings files. So these are the settings used in development mode when we're in Visual Studio and running with data on Windows. And this is the setting for our production environment where we're deploying to Linux and running with data on Linux. So this is where we're specifying our environment variables essentially for our deployed application. So let's close those down. In the next step, basically, there is the ability to ship sample data. That's really just for demo purposes. We're not doing that in this case. The data is already present on the platforms where we're going to be running. We do have the option to ship a C++ runtime. If your deployment platform is going to be Microsoft Azure App Services, then App Services does not currently ship the C++ runtime that we need to run the Synergy environment. So we are including the C++ runtime in the deployment. And then basically it's saying what is the name of the zip file we're going to use, either timestamped or not, based on your settings in the settings file. And then basically if we're being asked to zip the results, then there's our zip command. We use 7-zip, so you do have to have 7-zip installed on the system, or change this command to whatever zip utility you want to use. So this zips the content into a zip file. If a zip file is successfully created, it then deletes the publish directory. And then its final step is concerned with, are we being asked to copy or FTP that file somewhere else? So if we're being asked to do a distribution via a copy, then we check that the target directory exists and we copy the file to that location. And if we're being asked to do an FTP, we make sure that we've got all the settings that we need, and we do we use WinSCP to do the FTP transfer. So again, you either have to install the free WinSCP application or change this command to the FTP utility of your choice. And that's essentially what the publish script does. So it publishes, it zips everything up, and it puts the zip file somewhere where your deployment process is going to then pick it up.
Once you have your service published and zipped, deploying it to Linux is simply a matter of copying the zip file to the Linux system, if you don't already do so during the publish operation, and then unzipping the file to the folder where you would like the deployed files to reside. Of course, you need to configure any environment variables that your application might need, And as we already mentioned, a good place to do that is in the appsettings.production.json or whatever environment name you're using, configuration file. Finally, make sure that the hosting program, services.host, as well as any traditional bridge launch script files are marked as executable. Once deployed, starting the application is as simple as executing the services.host application. Of course, in a production scenario, you'll need to ensure that the service is started at boot time. And of course, depending on which Linux distribution you're using, you can do that using the operating system's init or systemctl or whatever initialization system is used for that distribution. Before we go on to see an actual example of a service running on Linux, there is one more thing that we need to know, and that is related to the use of SSL and encryption certificates that are required because the default Harmony core services are only accessible via HTTPS. There is an HTTP endpoint, but when accessed, it simply redirects to HTTPS, so we do need to make sure that we have appropriate certificates. In .NET Core and 6 development environments on Windows, ASP.NET Core creates a self-signed developer certificate and registers that certificate as trusted by the developer's Windows system. On Linux, for developing and testing, we must take a couple of additional steps to provide a copy of that certificate on the Linux system and to tell the ASP.NET application to use it. We can also use a similar approach to define which ports the service will listen on for both HTTP and HTTPS. There are several ways to provide those values and settings, but the simplest way is to use environment variables, similar to the ones that you'll see on this slide. Clearly, for production scenarios, you would need to do something different, especially if your service is publicly accessible, in which case you would need to obtain a real SSL certificate from a trusted vendor, and most likely use a more secure mechanism to specify the password associated with the certificate to the application at runtime. Several alternatives are available for doing that, including a mechanism called App Secrets, or even using something like the Azure Key Vault service. Okay, let's take a look at a quick demonstration of deploying a published service to Linux, running it, and accessing it.
Okay, here we are back in Visual Studio, and in this demo we want to do three things. We want to see how to deploy our published application to Linux, how to start the application on Linux, and how to interact with the application. So the first thing I'm going to do is I'm going to use Windows Terminal to open a connection to my Ubuntu 2204 Linux system that's running under WSL2. In here, I've done a bit of setup already. We do already have a data folder. So if I ls data, you will see that we have some ISAM files from the standard data set for the Harmony Core demo application. And we also have a file called setup, which sets the 4 environment variables that we need to configure the ports and to configure the SSL certificate and the password. Clearly, again, you wouldn't want to do it this way in production necessarily, but this is fine for development. Let's execute the setup script. And so we've got our settings in place. We've also got a Synergy environment already installed in here, so I do have licensing. The licensing is using the new Synergy 12 license forwarding, so these keys are coming from my Windows license server on the laptop that's hosting this whole environment. So we should be good to go. What we need to do is let's make a directory to put our service files in, and let's cd into that directory. Now, I don't need to transfer the zip file here because this is WSL2, so my Windows file system is available to me. So I can simply unzip from the directory, my mounted directories. The files are on my D drive in a folder called Harmony Core Docker Demo, and they're in that zip file that the publish.bat created, Harmony Core service-linux.zip. So if we unzip the files directly from the Windows file system where the zip file resides into the Linux file system, we now have all of our files that make up our runtime service, including the Synergy runtime, the .NET runtime, all of our application binaries, and other files that it may need. Okay, as we mentioned before, we do need to make the hosting program and the launch script executable. So we'll use chmod plus X to do that and make those executable. And there's one final thing that I do need to do before running the application, which is this environment is set up for the next demo down the line when I run this in containers, and my data is in a slightly different place. So I'm just going to edit the app settings dot production JSON file, and I'm going to change the location of the data here to /home/stevei/data, which is where we saw the data folder below our user directory just a couple of minutes ago. Oops. So we'll exit and save that file, and now we should be in a position to be able to run the service. So let's start the service by running the services.host program just like you do on Windows. And it launches up, and we can see it's listening on ports 8086 and 8085. Now with WSL, the Linux system shares network ports with the Windows system, so these can be accessed both from Linux but also from Windows. So if I go to a web browser on my Windows system and I go to localhost :8086, which we have there, you can see that here is the home page of the service that's being accessed from the Linux environment on the WSL2 system. And sure enough, if I go to customers and ask for all customers, the customary slight delay while it spins up the service for the first time, if we refresh that, it'll execute much faster. And you can see we're interacting with the service. So let's go back and just run a couple of other queries, the first 3 customers, for example, and that's exactly what we receive. So there we are. That's how you deploy and run and access a Harmony Core web service on Linux.
So we can run our Harmony Core service on Linux. But what other opportunities does that present us with? Well, these days, many people are interested in ways of achieving highly scalable and highly available computing environments. And many others are interested in ways of deploying applications and services via public cloud vendors like Microsoft Azure, Amazon Web Services, and Google Cloud. One increasingly popular way to achieve all of those things is to deploy your applications or services in containers, such as Docker containers, and to operate those containers via an orchestration tool such as Kubernetes. Well, that's exactly what we're going to do here. Well, at least the Docker part. Kubernetes can be pretty complex, so we'll get into that at some other point. There are 2 main terms that you'll need to understand when starting to learn about Docker, and they are images and containers. An image is essentially an executable package that contains a highly stripped down operating system, the application or service to be executed, as well as anything else that is needed to run the application, except data. So all of the executable runtimes and libraries that are required are loaded into the image. In very simple terms, a container is a running instance of one of those images. An orchestration tool like Kubernetes might spin up one or more containers when an application starts, and might then add and remove containers in a cluster as demand for the application or service grows and shrinks. Also, if a container fails for any reason, the orchestration tool can replace it with a new copy. Docker has the concept of a repository, which is an online library of images that can be used. Some of these images are used as a base image to make other images. For example, an Ubuntu image might present a base operating system, while other images are directly usable. For example, there's a WordPress image that you can use to spin up a container that hosts a WordPress website very easily. The Docker repository is called Docker Hub, and it's available at hub.docker.com. To define the contents of an image, developers use something called a Docker file. This is a file that contains special commands to, for example, say start with a copy of a base image and add a few packages, install some applications, configure some settings, and so on. So a Docker file contains instructions on how to build a Docker image. This slide shows an example of a very simple Docker file. The from command specifies the use of a base image provided by Microsoft. who document the image as containing the ASP.NET Core and .NET runtimes and libraries, and as being optimized for running ASP.NET Core applications in production. The image is based on a Debian 11 Linux distribution. The workdir command creates a directory if it doesn't already exist and moves into that directory, and then the copy command copies files from the local system into the image being created. And finally, the entry point command specifies the command to be executed when the container starts. This needs to be a command that will continue to run, because as soon as the associated process exits, the container will shut down. By default, Docker files are named Dockerfile, but you can use a command line option to change that if you prefer. At the bottom of the slide, you can see an example of a Docker build command that will read the file and produce a Docker image. The -t option tags or names the image. This slide shows how a hierarchy of images might be used. At the top, in blue, is an image called Ubuntu:2204. This image comes from Docker Hub. As a developer, I might want to start with a basic Ubuntu environment and then add various packages and tools that I typically need to install and configure or run my applications and environments. Remember, the base image, the actual Ubuntu image, has virtually nothing beyond a very stripped down kernel and very basic commands like bash, cp, cd, and a handful of other really basic things. The point is to be as small and fast as possible, so you only install what you absolutely need. Excuse me. Once I have my own Ubuntu image, I might have one or more use cases that need synergy. So in this example, the Syn1211 image inherits everything from my Ubuntu image and then adds synergy. I can then create other containers and add the binaries and other files needed to run a specific application, like these My Synergy app shown in green. Each one of these is an image. In other cases, I might need an environment that not only has Synergy, but also has .NET 6 installed. So the Syn1211 .NET 6 container inherits from Syn1211 and adds .NET 6 and other related tools. I can then inherit from that to make an image to host one of my .NET 6 applications. To keep things simple, our demo environment looks like this. We use the base image, Ubuntu:2204 from Docker Hub, to make an image called Linux Base. This just has a few additional packages and also has Synergy 12.1 pre-installed. Then we use that image as a base image to make a second image called Demo Service, where we deploy our Harmony Core service. The container will not contain any data. We will use a feature called Docker Volumes to map a data folder from our host Linux server into the container. This is typical. You would not want to put any data into an image because that data would be reset each time the container was started. And also, if you were to spin up multiple containers at the same time, you would want them all to be sharing and working together on a common set of data, not each have their own set of data. So data does not belong in images, but can be mapped into containers through various runtime mechanisms that are way too complex to get into here. There are several tools that can help you automate the process of working with Docker, not least the Docker Desktop UI for Windows. But as you are likely going to want to script and automate things like the process of creating images, I recommend becoming familiar with the command line interface, implemented through the Docker command. It's fairly easy to learn and works the same way on all supported platforms. The Docker command takes a wide range of first parameters indicating the subcommand to use, and many of the subcommands have additional parameters and command line options. I'm not going to get into the specifics here, that would take way too long, but the slide does list some of the more useful subcommands to know about when you're getting started. Most likely the first Docker command you will encounter is docker build, which processes a Docker file, follows the instructions therein, and produces a Docker image. Commands like docker run and docker stop are used to start and stop containers, and commands like docker image ls and docker container ls show information about the images and containers that currently exist. There are more commands to control all aspects of the Docker environment, And of course, they're all well documented in Docker's online documentation. To simplify the process of getting started, we provided a number of Linux shell scripts to help you with operations like Docker build and Docker run, which do tend to require quite a few command line parameters. You'll see some of them being used in the following demonstration.
In this demonstration, we're going to show how you can take a Harmony core service that you've developed on Windows and deploy it to Linux, similar to what we did in the previous demonstration, but this time we're going to deploy it to Linux inside a Docker container. So in the environment that is part of the GitHub repository that supports this session, and you can download and play with yourself at a later date if you wish, you'll find this folder called Docker. Inside this folder are various setup files that we will use to create our Docker images and run Docker containers. You'll also find that there's this bin folder where we ship various shell scripts, which I mentioned earlier, that can be used to simplify the process of building images and running containers and controlling things and so on. Let's take a look in more detail at the specific files that are provided. In our example, we're going to use two images. We're going to have a base image, which is essentially a Linux system with Synergy installed. And then we're going to have a second image, which is based on that first image and adds a deployed Harmony core service. So in here, you'll notice we have two Docker files. They are called linuxbase.dockerfile and demoservice.dockerfile. And each of those has associated setup and startup scripts. The setup scripts essentially configure the environment. So let's take a look at the Linux-based setup script. And this configures essentially the runtime environment for the container. So actually, it also configures the build environment in this case. So what this script is doing is, first of all, downloading the Synergy installer if it's not present in the local directory. So it'll download it one time. And then we are specifying that we are using a build parameter for our Docker build process called lmhost. And we're setting that lmhost variable to essentially the IP address of our host PC that's hosting this environment. And this little natty command in WSL2, at least with Ubuntu, will obtain the IP address of the Windows host that's running everything, and therefore the IP address of the license server, which clearly in this environment changes each time you boot up the system. So that will ensure we have the latest version of the license server IP address. And we're simply exporting that variable to the runtime environment also. These settings are used by our build and run scripts that we'll use later. In addition to that, we also have this startup script. And this is the script that the container will run on startup. And what we're doing in here is saying, well, we want to set up a Synergy environment. We want to reset the license server forwarding server to the IP address that we received via that LM host. And we want to start the Synergy license server, verifying that it did start, and then launch a bash script just so that that will just keep the container running. This image is just a base image. It's not actually going to be used for anything other than to be the source for other image or a base image for other images that we'll create. And then we have a Docker file. The Docker file essentially is the instructions for creating the image. So you can see here we are saying we are basing our base image on Ubuntu 2004. We're declaring that argument, lmhost, that we need. We are basically using apt update and apt install to install some additional packages that we need, both to perform the Synergy installation and to run our service. Dominit, if you're not familiar with it, is a package that has been designed for container environments. Normally, these cut-down Linux distributions don't have an init system. So Dominit provides a way of launching a shell script or a command or a program when a container starts. Then you can see we've got the various commands here to create a temporary directory, to copy the Synergy installation into the directory, copy the install script into the directory, and then here's the standard commands that perform a Synergy installation on Linux. When we're finished, we clean up those temporary files. Finally, we are providing a startup script, so that Linux-based.startup file that we just looked at that sets the license server and starts the license manager, etc. We copy that into image, and we make sure that file is executable. These final two steps are really just for demo purposes. We're appending term equals VT100 and a call to the setSDE script to the bash RC file. That just ensures that if we do connect to the container, we have a Synergy environment available, but that's not strictly necessary for running this demonstration. Finally, we specify that the entry point to the environment is the duminit package, and we use this cmd command to specify what duminit will do. So it's going to run a bash command, and it's going to essentially launch the Linux-based .startup shell script, passing in the IP address of the license manager. Okay, briefly, I mentioned this install.auto file, just so that you're aware of what that is. It's essentially a bash shell script that will automate the process of installing Synergy DE on a Linux system. Okay, let's see what happens when we get into our environment. So what I'm going to do now is use Windows Terminal to open up my Ubuntu 22.04 Linux distribution. And right now, I really haven't done too much prep on this. I'm going to CD to that Docker folder in our Windows environment. So I'm going to go to our MNT. This folder is on my D drive in the Harmony Core Docker, no, wrong one, Docker Demo and the Docker folder. Okay. And in there, we will also find a little setup script, and I'm going to run that setup script. All it does is it adds the bin directory containing our helper scripts to the path. So we'll just run that setup script. Okay. Now what I'm going to do is use one of our scripts called images, and that will show me a list of all the images I've got on this system. So as you can see, to save a little bit of time, I've pre-downloaded the Ubuntu 22.04 image from Docker Hub, and I've already run the build on the Linux base environment. That's the Docker file that we were just looking at. So Linux base is our image that has Ubuntu 22.04, a few additional packages, and Synergy 12.1 installed and ready to go. We've already looked briefly at the bin folder. Another one of our helper scripts is containers, and that will show us any containers that are running right now. So this is just showing you that right now we have a couple of images present, but we don't have any containers. If I want to, I can start an instance of the Linux base container using the run command. This is actually under the hood doing a Docker run command with some settings. And you'll notice that it shows us this long unique ID. That's actually the unique identifier of the container which has just been booted. If I use the containers command again now, you will see that we do have a running container now. It's based on the image Linux base. There's the beginning of its ID. That's unique as well and can be used to start and stop. And also every container that runs is assigned this unique name. In this case, Unruffled Hamilton is the name of our Docker image. So I can take that value, and if we wanted to connect to this image, we could say attach and specify the name. Again, attach is one of our helper scripts that's running a docker exec command to connect a bash shell to the running container. And now you can see we're inside the unique ID. This is the container running, and we're logged in. If I do a PS-EF to show the processes running in this container, you'll see here's our duminit system, and it has in turn launched our Linux-based startup script. You can see there the parameter of the IP address, which is our Synergy license server. There's our SYND, our license manager running, and there's the bash script that is just keeping that container alive. This bash script and PS-EF command are me connected into the container as well. So there's the container running. It doesn't really do very much. I do have Synergy running, so there's my licensing. And, I can run the Synergy runtime and so on, but other than that, there's nothing really else in the container. So we'll just exit to disconnect. The container's still running. So if we say containers, it's still there in the background. So if I want to get rid of it, I can tell it to stop. This is doing a docker stop command, and that container is now no longer running. Okay, let's take a look at the service that we're going to build, or the container that we're going to build. So we'll go back to our Visual Studio instance, and let's look at we've got a similar environment. So demo service.setup. You'll start to recognize some of the things in here. We've got the same logic that's obtaining and providing the current IP address of the license server via the LM host environment variable. We've also got some runtime volume mappings. So these are mapping folders from the Linux host that's hosting the container into a path inside the container. And these volumes are being mapped in order to provide the SSL certificate that we copied into Linux. That's mapping that certificate into the container in an accessible location. And it's also mapping our home data path in our Linux machine into /root/data inside the container. So it will appear to the container as if there is a data directory, although the data is actually on the hosting Linux system, not in the container. We also have various environment variables that are going to get set by our run script. And again, these are the ones we discussed earlier to define what the HTTPS port is and what the path to the SSL certificate and the password for that SSL certificate are. And on this occasion, we also have to do one extra step because we're going to be hosting a Harmony Core service that's exposing network services. So we specify those network services and essentially the port that the services are running inside the container and the port that we'd like to expose them on the host system outside of the container. And I'm just mapping them across to the exact same ports. So ports 8085 and 8086 will be used to access the service inside the container. We also have a startup file. This is the one, remember, that's going to run inside the container. It's very similar to the one we just looked at. We're still setting up a Synergy environment. We're still reconfiguring our license forwarding server to be the current IP address of the Windows host system. We're still starting the Synergy license manager process and verifying that it did start. But instead of launching a bash shell to keep the container running, we are CDing into our service folder and running our services.host. So we're activating our Synergy Harmony Core service. The Docker file that goes along with this is very simple. We simply base ourselves on Linux base. So that gives us Linux and the extra packages and Synergy. And now we simply need to add in the Harmony Core service. So first of all here, you'll notice we are overwriting the startup file. So we're removing Linux base.startup and providing demo service.startup, making sure it's executable. We are creating a folder called service we're moving to the service folder in our container. Okay. And no, we're not. We're creating the folder. Excuse me. This is the script that builds the image. So we're creating a root service folder and setting its access properties. And then here we are copying the zip file that contains the published Harmony Core service into the container, unzipping it. We're in the service folder, by the way, removing the zip file and setting the permissions on all the files that were extracted. We're telling Docker to expose ports 8085 and 8086 from the container, allow traffic into them. And then again, these final two things are just tagging on the bash RC, the Turbiz VT100 and set SDE into the login script, just so we can run Synergy if we connect to the container. And again, we're configuring Dominit, this time to run the demo service.startup file, again, passing the IP address of the license server. So that's the Docker file that's going to give us a new image called demo service based on Linux base, but with the Harmony Core service deployed into it. Okay, let's go and build that container. If we switch back to our Linux environment and we look at our images, you remember we have Ubuntu and Linux base, but we have not yet built that demo service container. So I'm going to use one of our helper scripts called build. This is just doing a Docker build command with various command line options and building the demo service image. So you can see it going through the various steps there. You can see all of the commands that we just discussed being executed. And very quickly, okay, so that took about almost 11 seconds. We now have a new image. So if I do an images, you'll see we now have an image called demo service. and it went up from 238 megabytes for the Linux, the base Linux system, to 338 megabytes. So we've added about 100 megabytes of files as our deployed Harmony Core service. Okay. If we, of course, look at any running containers, there's nothing running right now. So let's start the image or the container from the image that we just created. So I'm going to say run demo service. Okay. And again, it's launching the service, giving us a unique ID. If we use the containers script again, you'll see that we do have our demo service running as a container called Epic Elgamal. Okay, nice. So let's copy that name, and just as we did before, let's attach to that container. Again, we can do that either via its name or via its ID, either the short ID or the long ID. And you can see we're now in that container. Again, if we look at the running processes in the container, you'll see that, again, duminit was used as our init system. It launched demo service.startup, passing the host IP address. There is that process running our startup script. It in turn launched Cindy, and then ultimately launched services.host. So our Harmony Core service is running. And again, this bin bash and ps-ef is me connected into the container. As soon as I exit, those two processes will go away. And all the container is running is those four processes. So let's do just that. Let's exit from there. And the container is running still. Again, we can confirm that with our containers command. Remember, we exposed ports 8085 and 8086. Remember that in SL and Docker, those ports are all shared with the host system on Windows. So again, we should be able to open up a web browser, and we should be able to go, I've already got a shortcut for it, so homepage console, localhost 8086. So this is displaying the homepage of the Harmony Core service, but this time it's not running in the Linux environment in WSL. It's running in the Docker container that's running inside the Linux environment on WSL. And sure enough, if we hit one of the links, we should be able to interact with the service. There's an OData service. Let's do a more complex query. There's our complex query. And let's test one of our traditional bridge links as well, just to make sure that's operating as well. So this is us calling a Synergy routine to retrieve data, not just retrieving it through OData. Okay, so that's an example of the service running. Again, if we want to shut this thing down, then we can just say stop and the name of the container. And there we go. That's how you go about deploying a Harmony Core service in a Docker container.
To wrap up this presentation, let's quickly review what you saw. First, you saw the depictions of the various deployment models for Harmony Core services, including very soon the ability to deploy to Linux systems. You saw how to publish a Harmony Core service for deployment on Linux and how to configure and run such a service. You then saw a very brief introduction to Docker, which is a massive topic of its own. But hopefully we gave you enough of the basics to have a basic understanding. And finally, you saw how to deploy a Harmony Core service to a Docker image and then run it in a Docker container. Remember that while some of this may not be something you need right now, the main point is that running services in lightweight containers in conjunction with container orchestration solutions like Kubernetes can help you achieve scalability and high availability, and even let you deploy your services to the public cloud. For additional information on some of the topics discussed in this presentation, you can refer to the links on the slide, one of which is a link to a GitHub repository that contains the demonstration environment that I just used and all of the shell scripts and so on. If you are interested in assistance from Synergex with a Harmony Core or any other project, please get in touch with us via your Synergex account manager. Thank you all for joining this presentation. I hope you found it useful and interesting. At this point, I'm happy to take any questions that you may have.
All right. Thank you very much, Steve, for that presentation. It's now time for the Q&A portion of this session. So if you'd like to get our attention, you can go ahead and click the raise hand icon at the bottom of the chat, or you can go ahead and just start putting those questions into the chat and we'll address them as they come up. I see that there have already been there's been some discussion already going on in the chat here. Some stuff related, some unrelated. I think we can start at the top
Sure.
of the chat here. I see Gordon Ireland asked, can you deploy Synergy.net code with .NET data types on Linux, including lists, collections, and dictionaries? If so, can you import and use other .NET stuff?
And simply, Gordon, the answer to that is yes, as long as you're targeting .NET 6, not .NET Framework. So you would have some work to do if you've got existing .NET Framework code, but it's absolutely doable. We've got customers doing .NET Framework to .NET 6 migrations at this point in time, and as you know, we've migrated the Harmony Core environment over to it also. So yes, totally.
This next one, I think may have been addressed a little. Chuck Sinet asked, Ubuntu has a lot of tools built in. What's the experience running this on top of an Alpine Linux base image? As in more tools, more things to patch and change over time.
Yeah, I saw Jeff coming back about that as well. I personally haven't used Alpine, but I have no reason to believe that it wouldn't be not too much different basically on any Linux platform, as long as that platform supports the .NET 6 environment. I've certainly tried Ubuntu. I've done all this on Red Hat. I've done all this on Rocky Linux. I've done it, I think, on Debian. It really doesn't make too much difference which Linux you use. It's certainly in the Docker world, all of the base images are really, really stripped down, and you get, like I said in the presentation, you get very little, and you have to literally start adding commands. Even things like, basic stuff like wget is not there. You have to go install it if you want it. You've really got virtually nothing to start with. I know the Alpine image is particularly small, and Jeff was very proud last week of making an image with some usable ISUTL tools that was, I forget how big he said it was it 9 megabytes or something in that range, which is insane. But yeah, no expectation that it would have any issues.
Chuck Sinet also asked, are there any plans for Synergex to provide blessed images so we can just add source, point to data, and licensing and run? I think I may have asked this question last week, but
yeah. The answer to that, Chuck, is I don't know at this point in time. I'm not sure there's actually too much of a benefit to us doing that, because I totally get that what we might do is publish more and more Docker files that help you build an image that's got everything in place. But it's so easy to build that image that I'm not really sure there's too much benefit in us doing that. But we're certainly open to take that as input and have further discussions about it. Right now, if you look on Docker Hub, if you search for Steve Ives on Docker Hub, some of the images that I talked about, the SYN 12.1.1 and the SYN 12.1.1 Net 6, those images are out there on Docker Hub. And we can do that safely because the license, Synergy is installed, but the licensing is external to that. So you have to provide the IP address of a license server via configuration. So we're really not, there's no danger to us there. So there are some sample images out there. There are also some sample Docker files out there. In addition to the Git repository that I mentioned at the end of the presentation there, there's also another one. If you look on github.com/steveives/docker, there are various examples of how to put together various Docker files and supporting files, and all of the scripts that we use in the bin folder and everything are all there as well. So you're welcome to go and have a look at that, as well as the Harmony Core Docker demo repository that I mentioned in the end of the presentation. And both of those are public repos, so have at it.
I'm not sure if you want to touch on any of this WSL2 conversation that's been happening. I see Dan and Chuck have been going back and forth.
Is awesome. I've used it. I've tried to use it since it was since WSL1 was first a thing, and it didn't support Synergy initially, and then WSL2 came out and it didn't quite, and then all of a sudden Microsoft dropped in the bits that we needed to run Synergy in there, and ever since, and that was quite a while ago now, and ever since then I've used it fairly heavily. Pretty much
replaced Linux VMs for me in development. If I need a Linux environment, I just use WSL2 now. It is really awesome the way that it really natively integrates with the Windows operating system, with shared file systems, and Windows can access the Linux file system and Linux can access the Windows file system, and the way the networking integrates and shares ports is just absolutely awesome. Also, there's support for it in Windows Terminal, which gives you a great way of launching and hosting those things. There's support for it directly within Visual Studio. So if you're developing a project that you're deploying and targeting to the Linux environment with WSL2, you can attach the debugger directly to that WSL2 instance and processes running in it, and it's just super easy. I've set up environments for a couple of customers using a combination of Visual Studio and WSL2, and it really is, if you're primarily a Linux developer, it really is an awesome way to work. In terms of, I saw a question also about training for that. Actually, we haven't done any training on that. I guess we could. I did do a sort of 30-minute video, which was a sort of introduction to installing and developing in that environment. But I think it was more of an internal training session. If there's a demand, we could certainly do a version of that we can publish on the YouTube channel. Okay, it's 8:28. We should probably let people get to the next session, huh?
Indeed, I agree. Thank you, everyone, for your questions, and thank you for joining this session. You guys can join us in just a couple of minutes, as Steve just alluded to, for our next presentation, which is going to be The World Speaks JSON to You with our software development manager, Marty Lewis. So we'll see everyone over there, and have a great rest of your day.
Bye, everyone.